Hello everyone, and thank you for watching my video today on combinations and permutations. So to start here, let's just make sure we all know the difference between the two. A combination would be an arrangement of objects where the order does not matter. And a permutation is an arrangement of objects where order does matter. So really, that's the only difference between the two. Sometimes it could be hard to tell the difference between which one we're looking at here. So as we go through it, I'll try to explain, why each one is what it is. But really, it's just a matter of intuitively thinking about which one, does the order matter in this or not, okay? A quick example of a permutation would be a combination lock, because you have three numbers that you need, but the order does matter. Okay, you have to be this one and this one and this one. Okay. For a combination, really it could be, there's many different ways we can do a combination, but really it's just kind of if we were just picking randomly four choices of something, but it doesn't matter which four choices we picked in what order, that would be more of a combination. Okay. So to start here, let's just practice one of each. You see the two formulas up top. This is a permutation formula. This is a combination formula. They're very similar, except the combination also divides by r factorial. So consider the letters A, B, C, and D. How many different three-letter combinations can you make with those four letters? So we're going to go 4, choose 3. That's how I would say that. 4 combination 3. Another way to write that is like this. Parentheses. 4, 3, parentheses. Okay, and that's going to equal 4 parentheses over 4 minus 3, which is 1 factorial, times 3 factorial. All right, we could be able to do that without a calculator. 4 factorial over 3 factorial is going to be 4, and 1 factorial is 1, so our answer is 4. There are 4 different combinations, 4 different three-letter combinations we can make if order doesn't matter. So that means that like ABC and BAC would be the same combination. Okay. However, permutations, A, B, C, and BAC are different. Okay, so when we do permutation, for permutation 3, that's going to be 4 factorial over 1 factorial, which is basically just 4 times 3 times 2, or 24. So if order does not matter, then, if the order does not matter, then there's only 4 different combinations we can do. But if order does matter, we can mix those letters up 24 different ways. Number 2, Sarah has 5 pairs of jeans and is planning to bring 2 of them on her vacation. How many combinations of jeans are possible? Even if the word didn't say combinations in the problem, we should know this is a combination because it doesn't matter what order she picked them. It doesn't matter if she picked pair 1 first and pair second or vice versa. So this would definitely be a combination. All right, so this is, we have 5 pairs, we're choosing 2. So that would be 5 factorial over 3 factorial, 2 factorial. 5 factorial over 3 factorial is just 5 times 4 over 2. So this would be 10 different combinations. Okay. Now, this calculator can also do this in a couple different ways. So if you want to pause the video right now and get your calculator out, do that now. I'm going to get my calculator out on here as well. So there's 2 different ways we can do this in the calculator. One is by actually typing in the formula, right? So we're doing 5 and then math probability factorial divided by parentheses 3 factorial 2 factorial parentheses, and we get 10. But that way is a little outdated because the calculator can do a lot better than that. So if you have the older calculator, you have to type in 5 right now and then hit this next button and then type in 2. But if you have the newer calculator, you just go to math. Number 3 is combination. It'll put you here and then you hit 5 and you scroll over and hit 2. And there's our answer of 10. Either way, the answer is 10. All right, number 3, a standard poker hand consists of 5 cards dealt from a deck of 52 cards. How many different poker hands are possible? So again, order does not matter when you're talking about 5 cards, as long as you have 5 cards, right? So this is a combination. 52, choose 5. So it's going to be 52 factorial over 47 factorial, 5 factorial. Okay? So in our calculator, let's do 52, choose 5. And man, that's a lot of possibilities. 2,598,960 different hands are possible. How many poker hands contain all of the same suit? This is known as a flush in poker. Okay? All right, so if we want 5 cards are all the same suit, that means we got to choose the suit first and then choose 5 of those suit. So it's important to know a little bit about cards. In cards, there are 52 cards. Actually, I think I do. There we go. 52 cards in a deck. 13 of each suit. 13 diamonds, 13 clubs, 13 hearts, and 13 spades. Okay? So if we want to choose a suit, there are 4 suits, and we got to choose 1. So it's going to be 4, choose 1. We're going to multiply it by, in each suit there's 13 cards. You want to choose 5 of them. So 13, choose 5. So if we go back to our calculator,
Dear Jack of all tracks, they call me an SUV, but I can be what you want.
We're going to go 4, choose 1, and then times 13, choose 5. And we get 5,148 flush possibilities. You might think, oh man, getting a flush must be really easy if there's that many possibilities. Well, remember, and we'll talk about this later on in the chapter, it's this out of this. So the probability is actually still pretty small. All right, before we keep moving on here, quick note is very important here. If you see the word and, like we saw before here, can't remember where we saw that there, but I know we saw the word and. You see the word and? That's a key that you want to multiply your combinations. If you see the word or, that's a key that you want to add your multiplications. Sorry, your combinations. All right, so example 1, you're taking a vacation. You can visit as many as 5 different cities and 7 different attractions. Okay? If you visit 3 different cities and 4 different attractions, how many trips are possible? Okay? So you see the word and there, you're going to think, all right, I'm going to multiply. Cities first. That's a 5C3. And we're going to multiply because it's and. Attractions next, 7C4. All right, I got my calculator here on my desk. So I'm going to stop going back to the iPad calculator. You should know how to do that by now. But go ahead and do that in your calculator. You should get 10 and 35, which is going to give you 350 different trips. Letter B, suppose you want to visit at least 8 locations total. Okay, so that means you're going to 8 or 9 or 10 or 11 or 12, right? That's the way you want to think of it. 8 or 9 or 10 or 11 or 12. So we're going to add 5 different combinations together. There's a total of 12 different places here, right? So it's going to be 12, choose 8, plus 12, choose 9, plus 12, choose 10, plus 12, choose 11, plus 12, choose 12. All right, so that's going to go in our calculator. You can do them all one at a time and then add them up later, or you can simply just do it all in one line. Like, you can basically type that exactly as you see it there. Either way, you should end up with 794 different trips. C, suppose you want to visit at most 3 locations. Okay, so that would be 3 or 2 or 1 or 0, right? So that's going to be 12, choose 3, plus 12, choose 2, plus 12, choose 1, plus 12, choose 0. Okay, again, we can type that in our calculator one at a time, add them together, or all at once. Either way, you should get 299 different trips. From a group of 20 volunteers, you're choosing at least 18 counselors. So that would be 18 or 19 or 20. So that would be 20 choose 18 plus 20 choose 19 plus 20 choose 20. Add that up, we should get 211 different ways we can choose these counselors. Number 3, a local building supply company is hiring extra summer help. They need 4 additional employees to work outside and 3 additional employees to work inside. And how many ways can these positions be filled? There are 10 applicants for outside work and 5 for inside work. So, and means multiply here, right? So we're going to go 10 choose 4 for outside work times 5 choose 3 for inside work. Type that into your calculator, you should get 2,100 different ways. Before in a local election, there are 5 people running for president, 3 for treasurer, and 23 for cabinet. There's going to be 1 president, 1 treasurer, and 5 cabinets. How many different outcomes could the election have? Okay, so that's going to be 5 choose 1 for president times 3 choose 1 for treasurer times 23 choose 5 for the cabinet. Okay, go ahead and take that into your calculator there. And make sure you can get this answer here. 504,735 different outcomes. All right, so the next one, we're talking about poker again, using a standard deck of cards. How many ways you can get a 5-card hand consisting of the following? 2 aces and 3 other cards, 3 non-aces. All right, so for the 2 aces, there's only 4 of those. You can see there, 1, 2, 3, 4 aces. So we want 4 of those, and we're going to choose 2 of them. And, let's multiply. If there's 52 cards and 4 aces, that means there's 48 non-aces. So 48, and we're going to choose 3 of them. Into the calculator we go. 103,776 ways. Now let's go hands. How about 3 face cards? It's a king, a queen, or a jack, and 2 non-face cards. So there are 12 total face cards. So 12, choose 3 of them. And then 40 non-face cards. So 40, choose 2 of them. That can go to our calculator. 171,600 different hands for that. The last one, how about how many different combinations of 1 jack, 1 queen, 1 king, and 2 other non-jack, queen, or king? So there's 4 jacks, so 4 choose 1. 4 queens, so 4 choose 1. 4 kings, so 4 choose 1. And 40 other cards, 40 choose 2. And that would be 49,920 hands. That would give us that. All right, last slide here. A shipment of 25 TVs contains 3 defective units. And how many ways can the vending company purchase 4 of these units and receive 1 all good units? So if there's 25 TVs and 3 bad ones, that means there's 22 good ones. So we're going to go 22, choose, and we want 4 good ones. So 22, choose 4. Two good units. So that means 2 good and 2 bad. So 22, choose 2, and 3, choose 2, because there's 3 bad ones. We're going to choose 2 of those bad ones. 693 should be what you get there. At least 2 good units. That means 2 or 3 or 4. Okay, well, we already did this one and this one, right? So it's going to be 7315 plus 693. But we haven't done this one yet. So if we want 3 good ones and 1 bad one, that would be 22 choose 3 times 3 choose 1. Okay, and if we add that all up, we should get 13,321. Okay, that will do it for our lesson today on combinations and permutations. I hope you enjoyed it, and we'll see you again soon.